So I'm going to get you started on this one, and then I'm going to let you try it with your group, and then we'll go over it. So today we're doing applications. That means you're taking what I've taught you already about quadratics and applying them to story problems. So in other words, word problems. Here's my pep talk though. Word problems are no different than any other problem. They just have units with them, like feet, meters, hours, seconds, things like that. Okay, you're all still with me? So you are now a cookie salesman, okay? You are selling boxes of cookies, like the Girl Scouts. You can sell 60 boxes for $5 each. However, you want to make more money, right? You're a businessman, businesswoman. Every time you raise the price by $1, you're going to sell 4 fewer boxes. Why do you think that if you, we're talking about economics for a second, that if you raise the price of your product, you will sell less of them? Yeah, because there are certain people that are like, no, I'm not going to pay that price. Now you can raise it to a certain amount until you start losing too many customers. So what I want us to do is fill this out. I'm going to do the first line and then I'm going to pause the recording and let you guys try the rest of it. If the price is $5 each, so price is 5, what did the problem say we could sell? How many boxes could we sell? 60. Now, how would you get your earnings? What would you do with those numbers? Well, multiply them, right? 60 times 5 would be, you would make $300 cash money. Now, if you raise the price to $6, and we can do that one without a calculator, nice and easy, but I let you get up your calculator because you might need it for some of the rest of this. If you raise the price to $6, how many boxes are you going to sell? How did you get 56? Because that is correct. Get 4 fewer, okay? And you would multiply those numbers. I don't really expect that you know 56 times 6 off the top of your head. I believe you could figure it out without a calculator, but I'm going to let you use one for like the sake of getting through this quicker. I'm going to pause the recording. If anyone is watching this recording, it's going to look like this happened, instantly because we're going to fill out the rest of it. But I'm going to let you go and finish it, and then we'll make sure we all got the same answers, and then we'll talk about it. All right, so again, if you're watching this video, that looked like that happened in the blink of an eye, but I want everybody to look up here and check what you got with what I got. I need you to focus back there. Is this what you guys got? No. Okay, so here is the question. What price should you set your cookies at to get the most money? $10. So after that, you raise the price to a point where you lose too many customers and your money starts to go down again. Your earnings starts to go down. So if you graph this, what shape would it make? A quadratic, a U shape, a parabola. It would go up, you'd hit a maximum amount, which is right here. This is your maximum, and then it would come back down. Okay. That is what most quadratic applications are about. Objects go up and come back down, like a football going up into the air. It's literally rocket science. You are a rocket scientist. Rockets go up and come back down. That is what quadratics are. Have you ever heard that in T minus 3 seconds? You know where that comes from? Like, you have your quadratic, T minus 3 squared plus like 100, if that's how far up. Do you know what I'm saying? It's quadratic. That's where that comes from. Okay. Go ahead and close the Chromebook. We're not going to use that anymore. So we're going to take what we've learned and apply it to word problems. So that was just kind of like a lead into that. Now to find the vertex, I'm going to give you a teensy little formula here, or the axis of symmetry, because those are, both in the center, same thing, right? So the vertex or the axis of symmetry, it is this little formula, x equals negative b over 2a. That is your shortcut to get to that center point. Show you a couple of things on my little sticky notes here. You don't have to write this part down. I'm just going to show you. If you're like, hey, I'm not going to remember that. Well, a lot of you knew the quadratic formula. Do you remember this? Remember us, like it happened, we did this? All right, look, the negative b over 2a is just the first part of the quadratic formula. It's just without this. The point of a fidget is to help you focus better. So as long as that's working, you can do that, okay? All right, just checking. So it's just the first part of that formula. Now, when you do word problems, they ask you for different parts of the graph. So you have to just, be aware. But most of them are going to be a quadratic that like starts here and then comes down. It does something like that. If they ask you for the starting point or initial position, has anyone taken physics and heard that word like initial? Initial means starting. That would be there. If they ask you for the maximum, that would be here. And if they ask you for the, like when it landed, that would be here. So these are like the three important points that they usually ask for, but you just have to read. Like if you just read it, you all have good reading comprehension, you're going to be fine, right? So the path of a cannonball is going to go up and then gravity is going to pull it back down. Follows this function. Do you see how it's squared? Quadratic. Do you see how it's negative? It's going to be upside down, all right? Time is in seconds and height is in feet. I usually circle the units so I remember to put them in my answer. So we have height and we have feet. What is the maximum height reached by the cannonball and when does that occur? So looking at the graph, that would be this right here. Do you see where I'm pointing? That is your axis of symmetry. And so we're going to use that little formula that I just gave you, that negative b over 2a. So we're going to have x equals negative b. Now looking at the formula, which one of these numbers is b? B is a number. Good, the 32. It goes a, b, c. So 32, so negative b, negative 32 over 2 times a. Which number is a? Negative 2. All right, you can do this without a calculator. We're not going to need a calculator for any of the rest of this. That would be negative 32 over negative 4. And so what's that going to boil down to here? 8. Now the thing is, that is the x value. And if you put x equals, you'll remember that. So is that 8 the feet or the seconds? Which one is it? That's the seconds. So in 8 seconds, you reach that maximum height. So that's the when does it occur part. What do you have to do with that 8 seconds to get the actual height? Like that's the x value. How do we get the actual height? Yep, plug it into the function. Maybe I might reach for a calculator. Let's see how this goes. If we plug in 8 squared, all right, 64 doubled would be 128, but it's negative. So negative 128. Dude's got a calculator in his head over here. All right, plus, all right, 32 times 8. Let's say I made you do that without a calculator. Do you remember how to do multiplication like a 2-digit? It's a good skill to have, a 2-digit times a 1-digit at least. Do you remember how to do this from way back when? Like if you had to, 8 times 2 is 16. Every once in a while you have to. Sometimes you have to. 8 times 3 is 24, but then plus 1 would be 25, so 256. That sounds like that went well. Like say I made you do it. Sometimes on the AP exam, like on non-calculator questions, you have to actually do that to get through it. All right, and then plus 14. Now this is actually kind of nice because if you double 128, you get 256. So 256 minus 128 is 128 plus 14. So 142. Did I do that right in my head? You with the calculator, did I do that right in my head? 142. All right, 142 what? Feet. On a quiz or test situation, I would make the numbers nicer than that. We fought through it here in the notes. I like to make the notes problems harder though. Like we'll do those together and then I make the quiz or test one a little bit more manageable. Do you get what I'm saying? You just take 8, plug it in. All right, when does the cannonball hit the ground? Here's my little picture. Goes up in the air, comes down. This is when it hits the ground, right here. See what I'm saying? So you would take the whole equation and set it equal to what? 0. Good. So you're going to take this whole equation, negative 2x squared plus 32x plus 14 and equals 0. Because it's hitting the ground. It is 0 feet in the air if it's on the ground. Now, there are a lot of different ways you can get through this. And this was our lesson for last time is how you solve these. Here is what I would do. I would take everything and divide it by -2 because that would get rid of the -2 out front. 0 is a really convenient number because what is 0 divided by literally anything? 0. So it sort of absorbs any number. If you do 0 divided by -2, you just get 0. All right, so let's see. What is that going to give us? X squared minus 16x minus 7 equals 0. Now, the two main ways you would get through this is either factoring or complete the square. This will not factor. Why not? Like, it won't work. You can try all day. Yeah, this would be 7 times 1, but 7 plus 1 is not ever going to be 16. That's not going to work. So we're going to have to do complete the square. So you're going to copy down the first 2 terms, leave a little bit of a gap, slide the 7 to the other side. We have done this a bunch of times. You did it on your quiz. We did it in our last lesson. applying it to a word problem. So what are we going to add to both sides? 64, good. You take 16 divided by 2 is 8, squared is 64. The whole point is you can write it as something squared, blank squared. What would that be on the other side? 71. And then what's going to go in the blank? Good. X minus 8. Almost there. You just got to keep on going. What would you do next? Square. Now, what do you usually put in front of a square root? We are only going to do the positive version because there isn't negative time. So when it's a real world problem, you don't do the negative version. Does that make sense? If you put plus minus, I don't mark it wrong on the test because for heaven's sake, but you know, you're only going to get one answer and it's going to be positive. So x minus 8 equals square root of 71. I ran out of space, so unfortunately I'm going to have to come over here. And you get x equals what? Good. 8 plus square root of 71. And that's a great answer. Don't discriminate. What are the units? You can always look back at the problem. It says when. So seconds. Always just reread the problem to get that. If it says when, it has to be a time. If it says where, then that has to be a distance. Now, I encroached on the space for letter C, but that's not going to matter because this is actually the easiest one. What height is the cannonball launched from? In your picture, that's this right here. That's where you started. What is the answer? Just look at the equation without doing any work. Why is it the 14? Y-intercept, or you can think it went up 14, or you can think, oh, if I plug in 0, all those are correct ways to think about that, but 14 what? Feet. Yeah, go ahead. Oh, sorry, let me go back.
You divided all of them by -2, but don't you have to do something with the -2?
No, and that's what's great about 0. 0 kind of absorbs that number because 0 divided by anything is just 0. So no, you don't. If there was any other number besides 0, that would complicate it. But when it's 0, it's great. All right, so let's try another one of these. A ball gets thrown into the air. It follows this equation. Squared, that means it's a U shape. Negative means it's upside down. Objects go up, they come back down. Time is in seconds. Height is in feet. Usually you have seconds and feet. Just be aware, sometimes it changes and it'll be like yards or something else. Just make sure you read. All right. What is the maximum height reached and when does that occur? That's this point right here. What is that cute little formula I gave you for us to get that axis of symmetry, that center point? Negative b over 2a. Okay, so put x equals, so you remember it's the x part, or in this case it's t, whatever, that doesn't really matter. Negative b, what is the b number out of all this?
4.
4 over 2a, which is -2. So that is going to give you -4 over -4, which is 1 what? Second. Good. 1 second. So that's the when. How do you get the actual height? Plug it in. Now this is an easier one. We actually did the more difficult one first. If you plug in 1 for t, 1 for time, you're going to get -2 plus 4 plus 6. That's going to be 8 what? Feet. So after 1 second, it's at 8 feet, then it starts coming back down. This one is also a time. When does the ball hit the ground? That means you're going to take the whole equation, and can I change the t's to x's? Is that okay with everybody? Oh, wait, go ahead. I took 1 and plugged it back in for time.
Oh, how do you know which ones? This is going to sound tough.
So if you want the center, that's your negative b over 2a. Okay.
If it's second.
So times are going to be seconds. So that's the when. The x values or the t values, those are time. And then the output, like the input is time, the output is height. But it, like, if you use your common sense, it's going to make sense. Would it make sense that after 8 seconds, it's only at 1 foot? Like, if you just think about it, you'll get it right. Because it has to be one or the other. All All right, when does the ball hit the ground? You're gonna take the whole equation. I'm gonna change the T's to X's here. Are you all still with me? When I answer someone else's question, that isn't an invitation to just talk randomly. You should listen to the question and the answers so you benefit from it. And then what are we gonna do with that? Equal it to 0, because if it's on the ground, it's 0 feet in the air. Now here's what I would do whenever you have 0. Oh, go ahead, question. Okay. I would divide everything by the -2 because 0 divided by anything is going to just give you 0. I need you to focus back there. Okay. Like pick up your pencil and write this down. Okay. So what is that going to give us? Yeah, just x squared. That's kind of the whole point. Minus 2x minus 3 equals 0. Now, there's two main methods you're going to use to solve these: factoring and complete the square. On this one, we had to complete the square because it wouldn't factor. 7 wouldn't split to give us 16. This one, however, is going to factor. And so if it does factor, you probably want to do that because it's a whole lot less work. We want less work, right? And I'm not telling you to be lazy, but if you do less work, it's less likely you'll make a mistake. You have less places you might, have an error. So how is this going to split up? It will be 3 and 1. Good. We want a -2 in the middle. So -3, +1. And then you're going to set those equal to 0. Sorry, I wrote a little bit big. Mine's barely going to fit here. What do you get from the first one? Yeah, 3 and then -1. Now we're going to get rid of that. Why?
Because it's negative.
It has to be positive because it is time. You can't have negative time. And so it is 3 seconds. Just always make sure you put units on your answer if you have a story problem. And then see, what height is the ball thrown from, all right? That's the initial height. That's this part right here. No work, you just look at it. It's going to be that number tacked on at the end, the C value. And thank you for saying feet as well, 6 feet. That was actually an easier problem. I feel like the numbers were a little kinder to us in that one. We did the harder one first.
So
Listen to the question and the answer, guys. Go ahead.
The height of whenever the object is in the air is always going to be the third value?
The initial height, yes, is that third value. And the reason why is because if you plug in 0 for time, these two parts just go away. And if you plug in 0, that's when you started. Like at 0 seconds is like as our story begins. All right, this one's sort of like a scavenger hunt. Like you have to find all the things that you're missing. Here's our quadratic. Says we have a y-intercept of 27, axis of symmetry of -6. Find the zeros. So you have to take what you're given and try to find what you're missing. First thing I would do is try to figure out what A, B, and C are. Why is C 27? Very good, because we have that. Is the y-intercept. Now we actually have A as well. A is not written in front of here, so what is A? 1. There's nothing written in front of the x squared, so we know that that's a 1. So cool, we got that. What is the only other piece of information we have? Because you have to use what they gave you. Good, so you're going to take your -6 and set it equal to -b over 2a. That's that little formula that gives you your axis of symmetry or your vertex, the center point. They're both in the center. That is right here in the problem. So that was a given thing. Yeah, I made it up. No, that's a given piece of information. I'm getting there. Hold on. I'm not using them right now. I'm trying to figure out what B is.
The light isn't perfectly over. So that's why I was confused. Is that better? No, it's okay though. It doesn't matter.
Well, it does. I want you to be able to see it.
Oh, I can look at the paper.
Mona, can you turn off one light? And I prefer the one that's closer to the front of the room. Can you turn off the one that's closer to the front of the room? Thank you. Is that better? A little. How about now?
Yeah.
Okay. We'll try and make it work. All right. So we had A was 1. Let me get us all back together. We had C was 27. We're trying to figure out what B is. So we used the other piece of information that -6 is our axis of symmetry. Now, what did we say A was? 1. So 2 times 1 is just 2. And then what would you do to both sides to start solving that? You want to figure out what B is. You're going to multiply by 2. I'll use a different color. I don't know how much it's going to work, but we're going to multiply both sides by 2. And good, that'll give us negative 12 equals negative b, and the negatives cancel, so b is 12. Go us. So we have a, b, and c. Let's write out our quadratic. It would be 1x squared, or just x squared. And then what? Yeah, plus 12x plus 27, and I'm going to make it equal 0. Why would I do that?
So,
Yeah, the directions, right? It says find the zeros. Now, again, you can either factor or complete the square. I think this one will factor. And again, if it does, that's what you want to do because it's a whole lot less work. Good. 9 and 3. And then what symbols do you want? They're both plus. And so what are your 2 answers? 3. Perfect. And you get to keep them even though they're negative because that actually wasn't a story problem. We didn't have time and feet or anything. It was more like a take what you're given and figure out what you don't have. All right, last one. A rectangular plot is to be fenced in using the side of a barn as one side of the field. Why would that be good to use the barn that's already there as one side of your thing? You don't have to pay for more stuff. Like it's already there. Okay. So here is my picture of a barn. Don't make fun. All right. And what we're gonna do, I'm gonna use a different color for this, is we're gonna fence in these 3 sides. Trying to fence in your goats and sheep and pigs and whatever. We're being farmers here. You're fencing in this area. See what I'm saying? It's just you're using the barn because it's already there. Now we need some variables. Are you guys good with x and y? Is that okay? Okay. I'm going to call this x and these sides y. I like to go with x being the horizontal and y being the vertical. Do you know why I would do that? Yeah, it's same as a graph. Like make x this, and you can pick whatever letters of the alphabet you want. It's just familiar stuff is going to work better. Now we want the largest possible area. I'm going to use A for area. Do you know how to find the area of a rectangle? Yep. So in this case, it would be x times y. Now here's the problem. That's 2 different variables. So we're kind of stuck. So can you read the problem and see if they gave us any more information? Like I'm kind of stuck right now. So do we have anything else? You have 300 feet of fencing. So 300 is going to equal if you add these 3 sides together. So how would I write that? 300 equals, well, I have 2y, but did you label yours the other way around?
Yeah, I did it sideways.
Oh, okay. Well, you go do your own thing. Okay, 2y plus x. Again, you want to try and keep x the horizontal and y the vertical just for the sake of familiarity. And then you would want to get one of these variables alone, isolated. Which one would be easier to get by itself? Yeah, the x for sure. So we're going to subtract over the 2y. And we get 300 minus 2y equals x. Probably like, where on earth are you going with this, Miss Cole? Well, what we're going to do is take that and substitute it in for x in the other equation. I'm going to take the 300 minus 2y and do you know how substitute works? You remove one thing, replace it with something else. So in place of x, we're going to put the 300 minus 2y. And then you've still got that like leftover y outside.
Sorry.
Why would we want to do that? How does that benefit us? Like, why is that good? Same variable. We now don't have an x and a y. We just have y. So we got it in terms of one variable. What do you feel like we should do with this y outside? You kind of want to let your instinct kick in there. Yeah, distribute, multiply it through there. So that would be 300y minus 2y squared. And I forgot what we were doing. Can we reread the problem? What am I trying to find here? Like, what did we want?
The largest possible.
That is the maximum. Remember the cookies? And you found where the maximum was? It's going to go up and come back down. This is your center, your axis of symmetry, negative b over 2a. So we're going to do negative b over 2a. Now, which one of these is b? Because it's actually kind of tricky. Why is the 300 the b? Yeah, this would go out front. So the squared goes in front of it. So negative b over 2a. So which number is a? Negative 2. So that is going to give you negative 300 over negative 4. Negatives cancel, which is good because you can't have negative amount of fencing. That would be like an unfence. All right. So those cancel, and then 300 divided by 4. This 4 goes into 37 times. So 75? 75 what? Feet? Was it feet? I forgot to circle. Usually I circle. Yep, feet. So 75 feet is X or Y? Which one were we using here? Do you see how it was Y? So 75 is Y. Let me go ahead and just put that over here. This is 75 and this is 75. How could we figure out what X is? 75 and 75 would be 150. And we have 300 feet, so is 150. Good. Now, did we answer the whole question? Why do we have to multiply these together? Because it says find area. So 150 times 75, I'm going to be real honest, I don't know that off the top of my head. I would let you use a calculator for that. Does anyone want to estimate? Estimating is a good skill. Before I type this in, does anyone want to estimate 150? We're doing 150 times 75.
5,300.
700.
So 11,250. Now hold on, we're going to talk about units for that. It's an area. It's 11,250 what? Why is it square feet? Because it's an area. Areas are two-dimensional. It's whatever squared. Volumes are three-dimensional. It would be whatever cubed. Can you give me an example of a volume kind of thing? Like water filling up a container? Like cubic liters? Stuff like that? All right. Anyway. I guess liters already is, well, that's different because that's much, we get like cubic feet or whatever. But anyway, area is two-dimensional, volume is three-dimensional.